Welcome to video 4.1, where we talk a little bit about circles and we review some things from geometry. So in geometry, you don't need to write this down right now, but in geometry we often dealt with pictures that look like this. We had a circle, and there's the center, and we talked about the angle, which we call a central angle. We talked about arc length right there, or even arc measure. And just a quick review, if this was 30 degrees, the arc measure, which is related to part of the circumference there, that was also 30 degrees, but that was totally different than arc length. And so that's what we're getting at in this video, is the slight differences that we run across when we talk about angles versus length. So I'm going to erase this a second. There we go. And I'm just going to read through this up at the top. Suppose you have a circle with a radius of 1 inch and a central angle marked 30 degrees. How do you compare that radius to the central angle? There's really no good comparison there. And what happens if the radius changes, becomes 5 inches? How does that central angle versus maybe the arc length that you would see, how does that connect? So a long time ago, people had this conversation, and they decided to come up with a different way of describing those angle measures, and we call that radian. So I just want to describe that to you right now. I'm going to do that through a sketchpad picture. So basically, 1 radian is taking 1 radius of a circle and just kind of rotating that around the outside of the circle. So I'm just going to show that to you right now. There we have it. This right here, this part, this angle measure is 1 radian. It's just taking 1 radius and rotating it around. So I'm going to reset it, and it might help by maybe showing you the central angle here. I'm going to show you a semicircle. So there's 1 radian, there's 2 radians, there's 3 radians, and just a little bit more to get you half a circle. So 180 degrees is related to half a circle, and it looks like it's just over 3 radiuses, or 3 radians, which is really like pi. And I'm going to reset it one more time, show you 1 complete circle, and as you might guess, there's going to be just a little bit over 6 of these radiuses rotated around, which is like 2 pi. And if you think about it, our formula for circumference of a circle is 2 pi r. So it kind of makes sense that 2 pi radiuses would take us all the way around the circle. Okay. So just a very short review. And by the way, I will gladly pull this up in class tomorrow if you have any questions about this. But the big connection is that a radius and a radian are in some ways the exact same length, and that there are 2 pi, or just a little bit over 6, radians to go all the way around the circle. Very much like 360 degrees. Let me get my mouse back. Okay, so a radian, it's an arc length equal to 1 radius. There are 2 pi radians in a complete circle, so the ratio of radians to degrees is, I'll jot something down, we would say either let's see, radians to degrees, we'd say 2 pi radians to 360 degrees. A lot of times we say pi radians to 180 degrees. Okay, those are kind of the 2 big ratios that we often think about. So how many radians are there in 60 degrees? How would we kind of calculate that? So I often just, at least initially, just like to write out the work of actually showing the conversion here. If we start out with 60 degrees, I'm going to multiply by one of those conversion factors. So we just learned that there are pi radians, I even write out radians for right now, in 180 degrees. When I do it this way, the units cancel out nicely. Okay, the degree symbols cancel out. And so we just need to think about, how do I go through and simplify this sort of notation. Well, 60 over 180 is like 1/3. Okay, so whoa, what's going on there? That was not what I wanted to do. Okay. The 60 over 180 is like 1/3. We still have a pi on top, so in the end this is going to simplify to pi over 3 radians. Okay. So 60 degrees and pi over 3 radians are exactly the same thing. Okay, how many degrees are in pi over 6 radians? So now we're just doing this in reverse. Again, I like to start by showing some work here. So pi over 6 radians, I'm going to multiply by our conversion factor. So in this case, I'd multiply it by 180 degrees, or which is equivalent to pi radians. When I do this, it's kind of like saying 12 inches in 1 foot. I'm multiplying by something that is equivalent on top and bottom. It's almost like multiplying by 1 in the end. So again, if this concept doesn't quite make sense, make sure you jot down a question here and you're ready to discuss it in class tomorrow. So when I do this, the radians will cancel out, and also the pi's cancel out, right? One in the numerator, one in the denominator. So I just need to simplify 180 over 6. 180 over 6 will, in the end, become 30 degrees. And I picked these two examples for a reason. These are going to be some that we look at quite a bit down the road. So do make sure that you know pi over 3 radians is equivalent to 60 degrees. Pi over 6 radians is equivalent to 30 degrees. We'll stop right there. Jot down any questions you might have.